In this video, we're going to talk about planar graphs. Planar graphs are simply those that can be sketched in the plane so that edges don't cross except at a vertex that serve as endpoints of those edges. And a graph is planar if it can be drawn in such a way that no two edges meet except at a vertex that is an endpoint that they share. So it's this can be drawn that's critical as well to decide which graphs are planar. If you draw or have sketched a graph in such a way that edges don't cross except when they share a vertex and they cross at that vertex, then the sketch is a planar representation of the graph. So we can ask, for example, whether K4 is planar, even though our typical sketch of a complete graph might look non-planar to begin with. It's still a reasonable question to say, is this a planar graph? Well, it is certainly not a planar representation, whether or not the graph is planar. So we're going to do this for the four graphs that I have listed here, and you might pause and think about that if you didn't have a chance to do this already. We did do these in class, but you might look at them and see, and then as you come back we'll go through these then. So for K4 there is a planar representation, and the planar representation can be obtained by taking one of the edges on the inside and simply sketching it rather outside of the basic square that we see there. In other words, we might sketch it like so. Taking the edge here, I'll mark right there in green and putting it on the outside so that what we have remaining looks like this. This is there's what we have right here. So we have that sketch right there, and that then is an alternative representation of K4, which is planar. Now there are various ways that we have sketched it. That's just one of the ways that we've sketched K4 in a planar way before. So this is a planar representation. And indeed, K4 is planar. Okay, so that's the first one there. Let's look at Q3. So is Q3 planar? Well, Q3 we've drawn again in a couple of ways. One way is to just sketch it as you would normally think of as a cube, and take the edges that it has then, and in a cube just the edges there make it up, not the solid. And it's not a planar representation there, but we've also drawn it by opening it up, so to speak, and each of the what we will technically call regions here corresponds to a face or a side of the Q3. If you think of it now as a solid, then this let me color this one right here in the center may be the bottom one over here, like so. And then we have the sides. So the sides we'd have is one here is for this one in the back is that one over here to the left is this one, and then the front, that's an F, front face is that right there. What that leaves out is the top face, because this dot here I have right there represents the back one there. I should have used maybe a B for that, B for the back there. So the top face is actually out here. Here's the top face. Okay, so that corresponds to putting it on the outside. Anyway, that is planar. And so this is a planar representation of Q3. So Q3 is planar. as a graph because it can be sketched in that way. Q27 also can be sketched in a planar way, Q27. And a way to do that is to take the vertex set that has two elements in it and split them top and bottom, and then the vertex set that has 7 elements in it, I guess call these U1, etc., through U7 down here, and just lay those in a line there. And so we have a planar representation now if we connect the vertices in the set of 7 vertices, each to the 2 vertices in the other set of the bipartition, like so. So that is planar, and I've sketched it in a planar representation here. So the last one in this set of examples we're going to look at is Q33, and that's kind of interesting to consider, so we will do that here. So I think we'll certainly have enough room to start it right here, so let's start it right here at this point for Q33. And of course Q33 looks like the following. Let me go ahead and label these with W on the top, and on the bottom I'll label them with V. So V1, V2, and V3 on the bottom. And there's our graph. This is often stated in the context of a utilities problem where you have 3 houses here. Imagine these as houses. They're not going to be very fancy. 3 houses. And you have 3 utilities. You have, let's say, electric, so I'll use a little light bulb here. You have water, so I'll use a little faucet here for water. And you have gas. Say I'll use a little flame for gas to indicate gas right here. So gas. And what you want to do is connect these to the houses in such a way that the lines don't cross, if that's possible. And so the question is, can you pull that off? So I'm just drawing some of those, and that would be the answer. The same as saying that Q33 is planar. Is it or is it not is our question. And so at this stage I'm going to analyze this by first taking a part of it and drawing a part of it in a planar way. So let's just take the first 2 vertices in each of the 2 bipartition sets and look at what that would give us here. So if I draw that, just those right there, so I'll have W1, that would go to, well, what I'm going to do is put V1 down here. That's okay. But I'm going to put V2 up here and W2 down here because W1 has to connect up with the 2 sets, the 2 vertices from the bottom bipartition set, the V set, and W2 must also do that. So I'm just taking the W2 up here and putting it down and putting the V2 up there, and those are the 4 edges that we would have in this configuration, but just flipping this down and that up like so, right? So now we have the other 2 vertices to put in here and the corresponding edges. So one way to think about this is let's next place W3. W3 can either go out here or it can go inside, and inside I would put it right in the middle, and then the edges there, W3 would have to connect up with the V's but not the other W's, right? So in this case I've actually finished the configuration. Down here I haven't. Let's go ahead and see what that would look like if I have that W3 down here. Then let me go ahead and do the lines from W3 in green here, just as I did before. So W1, V2, V1, and W2. So that's what I would have there. But the same sort of sketch results if I take the vertex W2 and move it up in there. Then we'd have a configuration that looks like so, and the V3, the W3, excuse me, the W3 becomes the lower right-hand corner instead of the W2. So we do get the same configuration. It's just this time we'd have the W2 on the inside, the W3 out here. W1, V2, V1. So the same kind of configuration results with one more vertex to be put in there. So we might as well focus on this one since the other one's going to work in exactly that way. So we will assume then that we have this configuration here, and because we know we're going to have that configuration, it's just which vertices we've put there. And the way we've done it, we put this as a W3. The other way just had the W2 in the middle and the W3 in the corner. The same sort of issues are going to result when we try to figure out how to put in now the last one, which is V3. Well, V3 can go in one of three places. It can go out here, so maybe V3 goes out here, or I'll draw another sketch to see what the other configuration might be. So this one, V3 might go right here, or we have the other configuration where V3 might go right here, right? Yeah. So, and for all of these, we have the same, everything else is the same, W1, V2, V1, W2, etc. Well, wherever we put it there, in any of those three places, it has to cross an edge. In this particular case, the edge V3 to W3 must cross one of the four edges out here. There's no other way around, so I'll write it W3 V3 crosses an existing edge. Okay. In this case over here, if we put V3 on the inside, remember W3 is that one. This is W3. So when I say we're putting V3 on the inside, I mean V3 would be some vertex in there. But here, if V3 is here, then the edge W1, V3 must cross one of these edges, there, or one of these two here to sneak all the way around on the outside. So W1, V3 crosses an edge. And you can see the same thing's going to result here as we go from V3 to, in this case, it's going to be W2. That edge will have to cross another edge. So what follows from this is K33 is non-planar. Now later on we'll see a different way to show this. This illustrates that it's not trivial to show that something's non-planar by considering all the possibilities that you might have in order to make a planar sketch. It is not easy to do that in general, so it will be nice to have some simpler techniques to do that. We're going to stop here before we dive into some of those other considerations.